My name is Kaunda Kenneth. A technologist in Highways Lab. I'm going to show you this experiment. It's called Aggregate Impact Value, AIV in short. So this experiment is a relative measure of the resistance of aggregate under sudden impact. In other words, under sudden loading. The way the aggregates will resist the sudden loading of sudden loading applied on it. So for this experiment, we have the apparatus, the aggregate impact value apparatus. We have our sample. First, I want to talk about the sample. The sample should be tested when it's dry. When it's not dry enough, it should be oven dried for about 4 hours under a temperature of 110 degrees and then left to cool before testing. Also for this experiment, the type of aggregate that we use is the aggregate passing sieve number 14 millimeters and retained in 10 millimeter sieve. And that's the 1410 we are talking about. Or we also have a tamping rod of a standard specification of 10 millimeters diameter and 23 centimeters or 230 millimeters long. We also need, for this experiment, a sieve, sieve number 9, the BS sieve number 7, I mean, of aperture size 2.36 millimeters. We require also a wire brush that we'll use. And we also need a weighing balance to 1 decimal place. So this is the metal cap for placing our sample for testing. And as you can see, it has got the external height and the internal height varying. So in other words, the internal height is shorter than the external height. And therefore, we have the chamfered edge. The chamfering protects the cap during the testing. It avoids the hammer from hitting directly into the sides of the cap. The hammer also is chamfered at the base. There is a little bit chamfering so that as it hits the sample in the cap, it doesn't hit into the sides of the cap. We have the handle that we use for handling the experiment. And well, of course, there is a safety pin. Safety pin. This is the safety pin. So once the safety pin is removed, you slightly raise the hammer and remove the safety pin. When the safety pin is removed, then the hammer will fall freely. And the height of fall in this case is 380 millimeters. We are expected to place our sample into 3 layers. The first layer is a third, second layer, 2/3, and then the final layer. Now, using the standard tamping rod, the height of fall should be 50 millimeters height. And we should compact, staggering the tamping rod to the whole of the sample surface. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 3, 4, 5. So that is 25 blows. The first layer. The second layer, again 25 blows. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5. Second layer. The third layer, which is the last layer, and you make sure that the last layer should actually reach the height of the chamfered internal diameter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 16, 17, 18, 20, 2, 3, 4, 5. So having done the 3 layers, we are expected to remove the excess and level it. So this is what we have, having placed our samples according to the standard. So we are expected to anchor it at the base and a little bit raising the hammer using the handle to remove the safety pin. So once you remove the safety pin, if you raise it further higher, the hammer will fall into the sample. So we are going to do 15 blows. And just like I had explained earlier, you do it in a span of 1 second. So we are going 15 blows, yeah? 1, so that is 15 blows. So after 15 blows, we make sure we lock it using the safety pin so that it doesn't fall. You should also be careful during the experiment so that you are not injured. So having done our 15 blows, we are expected using sieve number 7, which is 2.36 millimeters aperture size, to do the sieving. We are required not to continue we are required not to continue disintegrating the aggregates further, so you do it in a manner that you don't continue disintegrating the aggregates. So with our sieve, we are expected to do the sieving. So here we have the weight that has been retained, also the larger size, yeah? And we have the smaller size that is passing. So we're expected to get the weight of the passing. So using our weighing balance, I can tear the weight of the pan so that we have 0, 0, so that I measure the weight passing. So like in this case, the weight passing is 50.9 grams. So having the weight passing, you can also include the total weight. So using the wire brush, we make sure that all the particles that were retained are captured So here we have the weight that was retained. So we can include to get the total weight. That is now the weight that passed and the weight that was retained. So the total weight here is 689.9. Now, using the two values achieved, that is the weight passing and the total weight of the samples that we used to carry out the test, our aggregate impact value will be the weight passing all over the total weight times 100%. And we give our values into 1 decimal place. Now, the aggregate impact value is very important for an engineering project. And engineers use this to actually decide on the queries that they are going to use to get their materials for different projects. Let's say that like an engineer want to do a road project, yeah? So maybe you have different queries that you need to choose from, query A, query B, query C. But based on the materials that you are going to find from each and every query, you are expected to carry out these tests so that eventually you pick materials from the best query. Because in as much as the workmanship may be good, if the materials you are using are of low standard, then eventually the overall work of an engineer will be substandard.